All right, guys, today we are working on section 2.2 in our notes, or the part that says guided notes worksheet number 2. And we're still reviewing what functions are from last year in algebra. So yesterday, some of it was new. The input output part should have been reviewed. Today we're still reviewing what a function is. So a function means for every input there is only one output. So if I put something into my function machine, I should only have one answer come out. If I get multiple answers, then that's not a function. And why we even care about what functions are is we can write equations to represent them. If something is not a function, it cannot be represented by just one equation. So here it says a correspondence between two sets A and B is a function of A to B if and only if each member of A corresponds to only one member of B. So we say for every x, there is only one y. So last year in algebra, you did these mapping diagrams where you mapped your points with your x values to your y values. And as long as each x value only had one arrow extending from the left, it was a function. Okay, so every x only has one y. I'm not going to make us write out the reason for every single one, but that is the reason if you want to write it down. Every x has only one y. Right here, number 2, A goes to D, B goes to F, and C goes to F. This is still a function because even though this F is repeated, the Y value is repeated, we only care about whether or not the X value is repeated. We could still write an equation to model this because each X is only used one time. This number 3, though, is a different story. A is used and it has two different answers. That's a no-no. This is not a function. We would not be able to write an equation to represent that. And then 4, each x is only used once, so that is a function. So what is an easy way to determine if something is a function or not? An easy way is just to check and see if there's one arrow or none of the x's are the same. So sometimes I'll also give you a list of points. I'm going to write here that no x's repeat because they're not always in a nice diagram like this. So is this a function? Yes or no? Each x only has one line extending from it. So yes, it is a function. Is this a function? 2 is being used twice on the left as an x. So it is not a function. 2 is being repeated. And then here, each x only has one arrow coming from it, so it is a function. None of them are repeated. What is a mapping? A correspondence between the preimage and image is a mapping. So we talked about that a little bit in our last section of notes. So if and only if each member of the preimage corresponds to one and only one member of the image. So that's why, again, we're talking about functions. They tend to correlate with transformations and mapping very well. We're saying for every x value we put in, we're only getting one x prime value out. All right. So when we're talking about mapping things, we're saying that our blue is our preimage and our purple is our image. When we're mapping things, we can't have more points in the end. So here I could map L to O, I can map M to N, and I can map K to P. And it is a map because they all have one place to go. I'm not using any of the blue points twice. All right. Same here. I can go L to Q. I could go K to Q and M to R. So even though Q is used twice, that's okay because it's in the image. It's just like how we're allowed to have two Y's. All right. But none of my blue points are being used twice. So that's okay. That is a map. A mapping. All right, number 9. I can put L to T, I can put M to V, and I could do K to S. But I have this extra point here, and that's not allowed because that means I'd be using another point twice to get it there. So this is not a mapping because you would have to reuse one of your image points, or your pre-image points, excuse me. All right, KLM, this, I can map all of them onto T, and that's allowed. This is a mapping. Okay, so the gist is, I'm going to type it in here. Your image cannot have more points than your pre-image for it to be a mapping. That's the gist. All right, here, what is an easy way to determine if something is a mapping or not? I just told you, your image cannot have more points than your pre-image. That's the easy way. So I'm going to move that down a little bit. All right, so is this a mapping? Pre-image, A, B, C, D, E, F to G, H, I. Since this is my pre-image, it has the most points, that's okay. So yes, so even if we want to use an inequality, your pre-image has to be greater than or equal to your image in number of points. All right, so let's count these. We have 1, 2, 3, 4, 5, 6 here. 1, 2, 3, 4, 5, 6, 7 here. So this is not a mapping. This one we have 4 and 4, so that is a mapping. Not all mappings are useful. We don't want to start with a triangle and end up with a segment or a point after we map them. We want to study mappings that preserve the number of points between pre-image and image. So that's really what we're getting to with transformations. We're going to take a shape and we're going to do something to it. We might slide it, we might rotate it, we might reflect it, we might dilate it, which means we're stretching or shrinking it. So we're not really interested in these mappings that don't have the same amount of points. And we call those where they have the same amount of points. If you go from 3 points to 3 points, it's still a triangle, for example. We call that a one-to-one function in algebra, but we call it a transformation in geometry, which is the main overarching topic of this unit, is transformations. All right, so a one-to-one function means you have only one arrow of your x's to one arrow of your b's. So both of these are functions, but this one where it repeats f is not a one-to-one function. This would be like we take a triangle and we map it onto a line segment, but we're most interested in a triangle to a triangle, or in this case, a square to a rectangle. We're not as interested in a square being mapped onto a triangle. So transformations and one-to-one correspondence functions. A transformation is a one-to-one correspondence if it has the same number of points. We will only be studying transformations, which means they have the same number of points in pre-image and image. A transformation guarantees that our pre-image has 3 points, then our image also has 3 points. All right, so is this a transformation? On these, so if it's a mapping, pre-image just needs to have greater than or equal to the number of points as your image. But for a transformation, they have to be the same. So pre-image has to be equal to image. So here we have 1, 2, 3, 4, 5, 6 to 3. That is not a transformation. They have to be the same. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So no, still not the same. 4 to 4. So that would be a yes. All right, that's the end of our notes for today. You are now working on worksheet 2, and I believe that is pages 23 and 24. It's 2 pages today.